GRIAS Academy.
100 days, 100 themes, one goal UPSC Prelims. Hello all, welcome back to the program Mission Surya Phase 3, a STEM revision program where we deal with science and technology and environmental related current affairs completely in prelims perspective. So let's get started our today's session. Okay, let's start our today's session. In our today's session, yesterday as I told you all that we will be seeing the part 2 of the fuels, right? Yesterday we have seen few regarding fuels, alternative fuels and this sustainable aviation fuels, and the replacement of CNG is compressed biogas fuels and all. So we will see a few more fuels regarding the same thing, the theme of the fuels and alternative fuels in the amid of Hormuz crisis. Okay. Let's start with today's session. In today's session, we will see how hydrogen energy and types of hydrogen energy. Okay. Now, hydrogen is very much demanded in globally, because due to this fossil fuels and for using this fossil fuels like petrol, diesel and all, it is leading to a lot of global damage, right, due to the emissions and all. Hydrogen is one of the basic thing where it gives net zero emissions, like carbon, it cuts the carbon emissions, even it doesn't produce any emissions, so that it is very useful for the environment, so that it will be very helpful if we use hydrogen. So nowadays hydrogen demand is more globally. Okay, let's see few prelims and high yield facts of it. Let's see the basic properties of hydrogen. Okay, hydrogen is the lightest and more abundant element, in the universe. At standard temperature and pressure, it is a non-toxic, non-metallic, odorless, tasteless, colorless and highly combustible diatomic gas. Okay. Now, coming to the energy density, it possesses the highest energy content. By weight, but the lowest energy content by volume. By weight it contains the highest energy, and by volume it has lowest energy. Okay. Next, these are few basic properties of hydrogen. Moving on, let's see the emissions. It is a zero emission fuel. That's why we are backing up the hydrogen rather than using this fossil fuels and all. Okay, when burned with oxygen, producing only water and water vapor. These two are the byproducts of hydrogen, because by using hydrogens as the fuels, the byproduct basically is the water vapor, which is not such a damage to the global environment. So the we are globally in back of hydrogen. Okay. Next, coming to the color coded, based on the color coded, the hydrogen is of different types. Let's see what are those. The first one is green hydrogen. What is this green hydrogen? It is produced via electrolysis process, okay, of water using electricity from renewable sources, like solar, wind, etc. Okay, what are the byproducts of this? The byproducts are water or the water vapor, so that it doesn't have any carbon emissions, zero carbon emissions. This is what we call green hydrogen. The next one is grey hydrogen. What is this grey hydrogen? Which is extracted from hydrocarbons. This is extracted from hydrocarbons like natural gas, via which process? Via steam methane reforming. Okay, where carbon dioxide is released into the atmosphere. Currently constitutes the bulk of India's production. This is of grey hydrogen. Next, coming to the blue hydrogen. What is the sources of blue hydrogen? The basic sources of blue hydrogen is the fossil fuels. Okay, but the carbon dioxide products is captured and stored. The carbon dioxide is captured and stored when in the blue hydrogen when compared to the grey hydrogen. What happens in grey hydrogen? The carbon dioxide releases into the atmosphere. Okay, it mitigates the environmental impact. Okay, now moving on. The next one is brown or black hydrogen, which is produced via gasification of brown coal. That is lignite or black coal. Okay, gasification of brown coal and black coal. Okay, which is highly polluting with CO, carbon monoxide and carbon dioxide as byproducts. Carbon monoxide and carbon dioxide as the byproducts. Next is Tranqueous hydrogen. When coming to the tranqueous hydrogen, it is extracted via thermal splitting of methane. It is extracted by using thermal splitting of methane, which is methane pyrolysis. Uniquely, carbon is removed in a solid form rather than the carbon dioxide gas. Solidly, the carbon is removed rather than in the gas form in the case of carbon dioxide. Next, coming to the pink hydrogen. What is this pink hydrogen? It is generated through water electrolysis. Water electrolysis, which is powered by electricity from a nuclear plant. Okay. Next is the purple hydrogen. The purple hydrogen is made using nuclear power. And heat through combined chemothermal electrolysis. Okay. Next is the red hydrogen. Red hydrogen is produced via how? High temperature catalytic splitting. Of water using nuclear thermal energy. The next is white hydrogen. What is this white hydrogen? This is naturally occurring underground hydrogen. Okay. Basically, we are seeing these many types of hydrogens due to their production process, and the sources from they are available. Okay. Next. Moving on. Let's see a few keywords regarding this hydrogen. Okay. First is electrolysis. What is the electrolysis? This is a process using an electric current. It uses an electric current to split the water molecule to elemental hydrogen and oxygen. Means, see, this water molecule is splitted into hydrogen plus oxygen. One hydrogen molecule plus oxygen with the process of using electric current. This is called hydrolysis process. The next is steam methane reforming. This is the standard industrial thermochemical process. This is the standard thermal chemical process for producing grey hydrogen from natural gas. It is producing grey hydrogen from natural gas. Next is carbon capture and storage. How? The technology used to trap and store the carbon dioxide emissions. Which is crucial for distinguishing blue hydrogen from grey hydrogen. Okay. The next is methane pyrolysis. What is it? This is the thermal process which is used to tranqueous hydrogen that results in solid carbon. Okay. Next, these are few keywords of hydrogen. Next, coming to few value addition points, we will see National Hydrogen Energy Mission, which is announced in the Union Budget of the financial year 2021 to 2022. Okay. It aims to scale up green hydrogen production. And link India's growing renewable capacity with a hydrogen economy. Okay. The usage of hydrogen helps India achieve its emission goals. Achieve its emission goals in the Paris Agreement and reduce the import dependency of the fuels. Okay. Next, coming to the global context, Japan. Okay, Japan with Basic Hydrogen Strategy 2017 and South Korea with Hydrogen Economy Development Act 2020 are frontrunners in the Asia Pacific region. These two countries are the frontrunners in the Asian Pacific region for hydrogen policy making. Okay, next, coming to the India's edge, we have seen it in globally, right? Now let's see in the India's edge. What is the hydrogen feasibility in India is? It is favorable geography. It is a favorable geography and abundant natural elements give India a huge geographic advantage. By 2050, by the year 2050, India aims to produce 3/4 of its hydrogen. 3/4. Remember, 3/4 of its hydrogen by 2050. Remember this year also. By 2050, India is aiming to produce 3/4 of its hydrogen from renewable resources. Okay. India is also the part of the Global Mission Innovation Challenge for Clean Hydrogen. India is also a member of it. Okay. Next, let's see few applications of this hydrogen. You can see this fuel cell, right? Fuel cell. Okay, based on the electrolyte process, these electrons are hydrogen, excess hydrogen is coming out, hydrogen is going from the fuel, okay, air is coming in, this is the load, electricity load, anode, cathode, where the, due to this electricity process, this what we have seen, right, this water molecule getting converted into hydrogen and oxygen through the electrolysis process. This is what is happening. Okay, let's see. Hydrogen is utilized in fuel cells. It is used in fuel cells for transportation, spacecraft, propulsion and energy intensive industries like ammonia, like for fertilizers and all, and steel manufacturing also hydrogen is basically used. Okay, next. Okay, let's see few MCQ areas for hydrogen now. Okay, regarding hydrogen, the first one is the solid carbon trap. The solid carbon trap. This these are few topics where the examiner might trick you regarding this topics, like between the what you say, the types of hydrogen, between gray and blue, and between pink versus purple versus red distinction. The examiner might trick you with this statement in the statement based questions. So have a look on it. Okay, the first one is the solid carbon trap. Be careful that the statements regarding turquoise hydrogen, unlike other that emit carbon dioxide or capture it as a gas. Other types of hydrogens, they capture the carbon dioxide or else they release it in the form of gas. But the turquoise hydrogen, what it does, it leaves the carbon behind in a solid state. So examiner might trick you. Basically we will be understanding like carbon dioxide is emitted in the form of gas, or it has been trapped in the form of gas. So the examiner might trick you with this, like turquoise hydrogen which leaves the carbon behind in a solid state. The next is weight versus volume trap. As we discussed earlier, hydrogen weighs highest energy, has the highest energy by weight and lowest energy by volume. So examiner might trick you by shifting the statements like hydrogen has the lowest energy by weight and highest energy by volume. This would be the false statement. So have a look on it. Next is pink versus purple versus red distinctions. In the sense, pink hydrogen, purple hydrogen and red hydrogen has a unique feature, like these three are in common with their uses nuclear energy. All these three uses nuclear energy, but pink is specifically electrolysis via nuclear electricity, where purple uses chemothermal electrolysis and red uses high temperature catalytic splitting. Okay, these three are the differences. Basically the common thing is it uses nuclear energy. All three uses nuclear energy. The next is gray versus blue. Gray versus blue is the same thing. Both uses the natural gas for the production. Natural gas. But the only difference is that blue involves CCS. Okay, next. What is the current production status? When we see the current production statements in India, statements claiming India currently produces mostly green hydrogen. This is what if the statement is given, it is false. No, India is not producing green hydrogen as of now. It is producing more concentrated on grey hydrogen. Okay, so this have to be noted. Next. Commonly we will say, right, green hydrogen is being produced mostly in India. No, green hydrogen is not being produced mostly. It is the grey hydrogen which is being produced mostly in India. Okay, next. Moving on to our next topic. Our next topic is electric vehicles in India and IEMI report. Okay, electric vehicles. Even government of India is promoting to have electric vehicles rather than using this fossil fuel based vehicles and all, right, to reduce the emissions and even reducing the imports of crude oil from the other countries. Basically due to this the Strait of Hormuz crisis also, everyone is purchasing battery vehicles, electric vehicles rather than going with this fossil fuel like petrol based vehicles, right. So our main target is to get the electronic vehicles is to reduce the global emissions and to make India a net zero emission country by 2030. Okay, next let's see few prelims high yield facts. Okay, the report released. What is this report release? Is Niti Aayog in partnership with the World Resource Institute India published the report. What is the report? Is unlocking a $200 billion opportunity, that is electric vehicles in India. Okay, next, coming to the India Electric Mobility Index. India Electric Mobility Index. What is it? It is launched alongside the report. It is the first ever tool to elevate and benchmark the e-mobility progress of Indian states. E-mobility progress of Indian states. This is the first ever tool to evaluate and benchmark the e-mobility progress of Indian states. Now, coming to the evaluation, how this IEMI evaluation criteria, what is the criteria for evaluating the states is, it monitors 16 indicators across 3 crore themes. Okay, like that. Transport electrification progress. It is a demand side EV adoption, demand side electric vehicles adoption. Next is charging infrastructure readiness. That means network expansion and development. This is one. The next one is EV research and innovation, which is the supply side of R&D efforts. Okay, now see, IEMI, this reports state grouping. IEMI state groupings. How are these states grouped? These states are categorized into 4 tiers. 4 tiers based on their score generally. Okay, what is this? First is achievers. Achievers means 100% of score. Next is front runners, which have 60 to 90. 99, 65 to 99. Then is performers. Performers are 50 to 64 and aspirants are 0 to 49. Okay, in this way the states are being divided. The states are being categorized. First one is achievers, second is front runners, third is performers, fourth is aspirants based on their score from 100 to 0. Okay, next. In 2024 top rankings, what are the 2024 top rankings in electric vehicles usages? Delhi topped the index. Delhi topped the index with the score of 77, which is followed by Maharashtra, Chandigarh and Karnataka. First is Delhi, it is followed by Maharashtra, then followed by Chandigarh and followed by Karnataka. Okay, next. Coming to the e-mobility status in 2025. In 2024, okay, see, electronic vehicle sales surged to 2.08 millions. 2.08 millions, basically from just 50k in 2016. In 2016 it is just 50,000, but by 2024 what happened? It has been increased to 2.08 millions of sales of electric vehicles. Currently EV penetration stands at 7.6%, which is significantly short of India's ambition 30%. Basically India's aim is to achieve 30% target for 2030, but as of now we are standing in a state at 7.6%. Okay, next, let's see few keywords. Battery EVs. Battery EVs means the vehicles which run entirely on batteries. Okay, battery power. The next is hybrid EVs. Hybrid EVs are, these are combine and combine an internal combustion engine ICE with an electric motor. Okay, next, plug-in hybrid EVs. Plug-in hybrid EVs, these are feature both an internal combustion engine and a rechargeable battery, both can be plugged in. Okay, next is fuel cell EVs. Fuel cell EVs are generate electricity for propulsion. These generate electricity for propulsion utilizing fuel cell technology. Example hydrogen. Next is zero emission vehicles. These are the vehicles that emit no exhaust gases from the onboard source of power. Okay, next is battery as a service. Battery as a service in the sense a business model which is separating the battery from the vehicle, lowering upfront EV costs. Okay, next, these are few keywords which you have to know. Next, coming to the value addition for it. what are the core challenges to EV adoption, electric vehicle adoptions, why everyone are not taking up the electric vehicles, rather still using the fossil fuel vehicles like petrol vehicles and all. We'll see few challenges of it. The first one is financial and structural, because highly upfront costs, that is 2 to 3 times than the normal vehicles, okay, of ICE counterparts, and heavy batteries that reduce cargo payload for trucks, cargo payload for trucks. The 15-year scarpage rule also harms resale value. Not having the much resale value also one of the challenge. Next is charging infrastructure. Public charging is nearly 4 times more expensive than home charging. The outside charging is 4 times more expensive than the home charging due to operator margins and an 18% of GST. Not only the outsider, they generally charge an amount for vehicles charging, right? Rather than with that, along with it, 18% of GST is also included, so that the charging of the vehicles also being costlier outside. Okay, land scarcity, RWA safety misconceptions, and friction with distributions. Okay, over power supply connections, further delay network expansions. Okay, next, coming to the regulatory hurdles, an inverted GST structure like 18% of GST versus 5% of output GST. 5% of output GST, this is called the GST structure. This is the inverted GST structure, which locks up manufacturer working capital. It locks up the manufacturer's working capital, where additionally the Vahan database poorly categorizes EV data. It poorly categorizes the EV data, and the lack of unique battery IDs hampers tracking and recycling. These are the major challenges of EV adoptions. Okay, next, few government interventions. As we know, like Government of India is also promoting to have the electric vehicles rather than using this fossil fuel based vehicles. So let's see few schemes, government interventions. The first one is PM E-Drive scheme. PM E-Drive scheme, which is demand incentives across electronic vehicle categories, and PM E-Bus Seva, which is deploying 83,000 plus buses with a payment security mechanism. The next is PLI schemes for auto components and advanced chemistry cells, like targeting 50 gigawatts per hour domestic capacity. Okay, next, evolutions program. Evolutions program means by DST for startups, and GST reduction on electric vehicles is up to 12 to 15% of reduction to EV vehicles. This is what few government interventions and government policies which have come up for electric vehicle adoptions. Okay, now coming to the strategic recommendations and way forward, if we look into, like, shift from incentives to strict mandates. Example, higher taxes on ICE vehicles, strict ZEV production targets. Okay, the next point is adopt a saturation approach. Like target 100% electric vehicle mobility in 5 specific cities. Targeting 100 EV mobility in 5 specific cities within 5 years. Okay, next, establish a pooled fund. By establishing a pooled fund for commercial low interest loans, and launch a unified national EV app. For charging navigation and payments. Basically, this is major concern according to me. Like if we go out for having an electric vehicle, we don't know where these electric vehicle points are located. Charging points are located. For that also we need a app, like unified national EV app. Okay, next, coming to the global practices, these are a few way forward things which we can say. Coming to the global best practices, coming to first country is China, where 110 cities 1000 vehicles, 10 cities, 1000 vehicles program targeting public fleet electrification. Public fleet electrification. Next is Singapore, which is established EVE, which is dedicated subsidiary under the Transport Authority to coordinate charging infrastructure. The next is UK. In UK, what? Public-private funding initiatives like Faraday battery challenge to scale lab prototypes to commercial production. Okay, next. These are the global best practices by topping China, Singapore and UK, and coming to the few way forward things we have seen. Now, let's see few MCQ areas where what is a nodal agency trap? Nodal agency trap is like, remember the IEMI was launched by Niti Aayog. It is launched by the Niti Aayog with WRI India, not the Ministry of Heavy Industries or the Ministry of Road Transport and Highways. Basically, when we come across this electronic vehicles or any transport related things, we generally assume that Ministry of Road and Transport or Ministry of Industries, we consider this, but no, this IEMI is given by the Niti Aayog. The nodal agency for IEMI is Niti Aayog. Next, inverted duty structure. Next is the inverted duty structure. Like, be clear on this economic concept. Like, it occurs when the tax on raw materials. Like input at 18% is higher than the tax on the finished goods. We'll see it again. It occurs when the tax on raw materials is higher than the tax on the finished products. Okay, which negatively impacts manufacturers' cash flow. Means, see, in raw materials, when the input is 18%, the tax will be on inputs, and when the output is at 5%, also the tax is held. Okay, so be clear of this inverted duty structure. Next is index themes. Index themes, like, it ensures do not confuse the three themes of the EMIs. Three themes of IEMIs. Okay, it specifically evaluates demand side adoption. Charging networks and R&D innovation. It does not exclusively focuses on manufacturing capacity. It is not those three themes which we have seen previously. They doesn't stand for any manufacturing capacity. Rather, it evaluates the demand side adoption, charging networks and R&D or innovation side, not in the manufacturing capacity side. Okay, so have a note of this index themes also. Next is battery cost. Statements claiming like batteries are a small fraction of cost. Statements claiming batteries are a small fraction of the cost, because it is false, because batteries constitute approximately 40% of an EV's total capacity. When we take a electronic vehicle, basically the 40% of the cost is for battery only. The remaining percentage is only for manufacturing the model of a vehicle. Only 40% is for battery itself. So it is not the batteries are a small fraction of the cost. It is the false statement. Batteries are holding higher capacity of cost. Okay. So we have completed the parts of part 1 and part 2 of alternate fuels, like what you call the sustainable aviation fuels, regarding this replacing this fossil fuels and replacing this normal jet fuels, replacing the CNGs. We have seen the so many alternate fuels in the last part. In this part we have seen the efficiencies of hydrogen and using the electric vehicles by batteries and all. So I hope everyone liked this session. To have a detailed note on it, do visit our website and download the content from there. The link is provided in the description below. And do like, share and subscribe our YouTube channel for your UPSC preparation, and do follow our Instagram ID and as well as the Telegram channel for your UPSC preparation. I'll see you all tomorrow with another content of Phase 3 of Mission Surya, a STEM revision program which is related to science and technology and environment related topics. Okay, thank you.